Good morning, guys. This video is going to be on evaluating functions and function operations. So before we get started, I just wanted to talk a little bit about function notation. So function notation, if I have an equation that looks like this, y equals like something like 3x plus 2 or something, this is an equation. We have x values, we have y values. You know, if we take and plug in x values, we're going to get y values that go with it. So for example, if I were to plug in x equals 2 here, that would mean that x equals 2, right? That'd be give me an ordered pair. And when I evaluate this, I'm going to get what y equals. So 3 times 2 is 6, and 6 plus 2 is 8, so y would equal 8. Okay, so function notation, I would just take the y and replace it with f of x. So basically it's the exact same equation. It would give me the exact same x and y values. If I plug in x equals 2, I'm going to get f of x equals 8. So f of x just means my relation is a function, and it means my function's name is f, and that the input is x. But f of x and y are interchangeable. So if I were to graph this, this is the x-axis, this is the y-axis. I could also call this the f of x axis, okay? So when you're doing this, if I were to plug in 2, it just makes it a little bit easier. I'm going to say I'm going to take the function f, and I'm going to plug in an x value of 2, and then on this side I would actually replace the x with 2. And on this side, I'm not trying to evaluate anything or anything. This doesn't mean f times 2 or f times x. It just means my function's name is f, and my input is 2, or my x value is 2, and when I evaluate this side, that's going to give me the y value, or the f of x value. So f of x and y mean the same thing. They're interchangeable. This is just a new notation that we use for functions to say I'm putting in an input, and it makes it easy to say which inputs you want to put in. So if I wanted to calculate f of 5, for example, that I know I would need to go find function f, which is right here, and I would need to replace the x with 5. So that's all this is, this function notation, is it just makes it a little bit easier to say which x values we want to plug in, okay? So we're going to be evaluating functions. So basically, if we want to evaluate this function, f of x equals 4x minus 7 at f of 4, that means I'm taking x out and I'm putting 4 in its place. So I take this function here, 4 times x, I take the x out, I'm going to put parentheses there instead, minus 7. In the parentheses, I'm putting that value, so 4. So this would just be 16 minus 7, or 9. So f of 4 equals 9. Again, that is a point on the graph, x being 4, y being 9. That's a coordinate on the graph. If you're just asked to find f of 4, you're just being asked to find the y value, so that would be 9. So f of 10, take the same function, replace x with 10. So this would be 40 minus 7, or 33. Okay, so let's try a couple more examples here. If I have a negative x plus 5, I'm going to be plugging in 4 where x is. So this is going to be, the negative is still going to be there. I'm going to replace x with parentheses, and then whatever's inside my parentheses here is what I'm putting there. So this would be negative 4 plus 5, which equals 1. Now if I put a negative 2 in here, I've already got the negative out front, so negative 2 plus 5 is 2 plus 5, because when I have a negative times a negative, I get positive. So that would be equal to 7. All right, so let's just try a couple more examples with evaluating. So if my function is, whoops, I forgot my f of x here, f of x equals, and again, f is just the name. It could be any letter here. I could have g of x, or h of x, or any other letter. This is just standard, I guess, to say your function is f. If you have more than one, you're probably going to use f and g and h, but either way, you can call your function anything you want. Here, I want to plug in 4, so I'm going to replace the x in the function. Everywhere I see an x, I'm going to put a 4 instead. So sometimes it's helpful just to write the equation the same as it is above, just putting parentheses where the x's were. And then in the parentheses is just going to go that number you want to plug in. Now on this one, we got to be careful with our order of operations. So remember, we do exponents before we multiply. So on this one, I would do 2 times 16. because I would want to square for first before I multiply it by 2. If you multiply it by 2 first and then square it, you're going to get the wrong value here. Plus 12 minus 2. So that'd be 32 plus 12 minus 2, or 44 minus 2, which is 42. Okay, and then now negative 1 is going to be our input now. So I'm putting it in here. So f of negative 1 would be equal to 2 times negative 1 squared plus 3 times negative 1 minus 2. So negative 1 squared, negative 1 times negative 1 is positive 1. So this is just 2 times 1, or 2. 3 times negative 1 is negative 3, and then minus 2. So 2 minus 3 is negative 1, and then minus 2 more would be negative 3. Okay, lastly here, my input is 2x. So it's not just a number now, it's actually a little expression, 2x. But I'm going to do the exact same thing. I'm going to take this x out, and I'm going to put in what's inside the parentheses. So again, write the function, putting parentheses everywhere you see an x, and then take what's in those parentheses and put those there inside each of those. So 2x squared, well that means 2 squared times x squared, which is 4x squared times 2. So 8x squared, right? 2 squared is 4, and then x squared, and then I'm multiplying that by 2. So that's 8x squared plus 6x minus 2. So on that one, we're not going to get just a number, right? That one has x's in it still. But that would be what the function is if I plug in 2x for x. Okay, so the next thing we're going to look at is function operations. So function operations just means we're going to be adding functions, subtracting functions, multiplying them, and dividing them. So the notation here, I can see that I have two functions. My first function is named g. So it says g of a equals a minus 3. My second function is named h. So h of a equals a to the third plus 2. It's asking me to find g plus h of a. So that just means I take function g and I add function h. This a right here doesn't mean times by a, right? It means my input is a. That just means a is the input variable for the functions. So now I'm going to add them together. I'm going to take function g, which is a minus 3. I'm going to put parentheses around it. If you do that and you put parentheses around them each time, you're going to make less mistakes. And then I'm going to add function h, and function h is a to the third plus 2. And so this would just be g plus h of a. Again, you don't evaluate anything over here. This side is just telling you what to do. Take function g, add function h, your input is a. So this is just like adding polynomials, right? So I just want to find like terms and combine them. So a to the third has no like term, so I would just write it as a to the third. I'm starting with a to the third because it has the highest exponent and I want my answer in standard form. So the second highest one is a, and there's no like terms with a, so I would just write plus a. And then I have negative 3 plus 2. Negative 3 plus 2 is negative 1. So a to the third plus a minus 1 would be functions g and h added together. Subtracting functions, same thing, but different operation. I'm going to take function f and I'm going to subtract function g. So function f is 2t minus 4. Again, put parentheses around it because here I'm subtracting, right? And if I subtract an entire function, I need to make sure that negative gets distributed correctly. So I'm going to subtract function g, and function g is equal to 3t plus 1. So remember that negative in there needs to distribute to both terms over here. So this would become negative 3t minus 1. So 2t minus 3t is negative 1t, or negative t. And then negative 4 minus 1 is negative 5. So this would be negative t minus 5. Okay, then we want to multiply functions. So here I have function g and function h. I want to take function g and times it by function h. Again, that just means that x is my input variable. So I'm going to take function g, which is negative x, and I'm going to multiply it by function h, which is x squared minus 2 minus 2x. So basically I'm just taking this negative x and I'm distributing it into the parentheses here. So negative x times x squared would be negative x to the third. Negative x times negative 2 would be plus 2x. And then negative x times negative 2x would be plus 2x squared. Now I could rearrange this so that it's in standard form. I want the highest exponent first, so negative x to the third plus 2x squared and then plus 2x. Just changing the order of those last two here to make sure it's in standard form. It's not the biggest emphasis here, but it's always a good idea. All right, now we're going to divide functions. So function f is x squared plus 6x. Function g is x minus 1. I'm going to find f divided by g of x. So take function f, which is x squared plus 6x, divided by function g, which is x minus 1. I could check for this to see if it would simplify at all. I don't believe it's going to. On the top, I could factor out an x. If I pull the common factor of x up here, I'm going to get x times x plus 6 over x minus 1. So there's no matching factors top and bottom. On these, I'm really just more concerned that you know that you just take that function and put it over that one. So x squared plus 6x over x minus 1 would be fine. Okay. All right, so there's one other function operation called function composition. So function composition is going to have this symbol right here. So it looks a little bit like times with a dot in there, but it's not a dot, it's an open circle. So what this means is I'm going to take function g and I'm going to plug function f in to function g as the input. So I guess I could write this another way. I could write this as g of f of x, or n, since this one has an n. So basically what it means is that the entire function of f is going to be my input to g. I'm going to take the n's out of function g, right? So here's 2n minus 3, that's function g. So I'm going to take the n out and put parentheses where the n was. And then my input, or what I'm plugging into the function g, is the entire function f. So I'm going to take function f, which is n to the third plus 3n, and that's what's going in here where n was in function g. So it becomes 2 times n to the third plus 3n minus 3. Okay, so it's always the first function listed is the one that you use, and you take the n out, right? And you put parentheses in its place. The second one listed is always the one that goes inside. So n to the third plus 3n is going to be what replaces n in that function. And then you just want to go ahead and simplify. So this would be 2n to the third plus 6n minus 3. That would be function g evaluated at function f. Okay. So now we're going to do the same thing here. I have f of a equals a plus 5. I have g of a equals 4a plus 2. I want to take function f. So here's function f. I'm going to do a plus 5, but I'm going to take a out. So it's just blank plus 5. And then in that blank, I'm putting the entire function g, the second one listed. So I'm going to replace the a with 4a plus 2. And now I can go ahead and simplify this. 2 plus 5 is 7, so this would just equal 4a plus 7. All right, guys, that's it for today. Go ahead and try some of the examples on your homework assignment. If you have any questions, please don't hesitate to email me. I can answer emails all day, and if you would like to set up a Zoom meeting, if you're struggling with things, you can go ahead and just email me and we can set that up. Have a good one, guys.